Today's daily LeetCode problem of the day is minimum swaps to group all ones together, part 2, number 2134. For this problem, a swap is defined as taking two distinct positions in an array and swapping the values in them. A circular array is defined as an array which we consider the first element and the last element adjacent. So we're given a binary circular array, nums, and we want to return the minimum number of swaps required to group all ones present in the array together at any location. So for this problem, let's look at example 1. We have an array of zeros and ones, and it's a circular array. So once we get to our last element, we're going to swap back to our first element, and we want to find the minimum number of swaps it takes to get all of our ones grouped together. So in this problem, we can swap this one and this zero, and then all of our ones are grouped together. Let's look at this example. Okay, so for our second example, we have two ones that need to get swapped. So we can swap those two ones with these two zeros, and all of our ones are in a row. So how are we going to approach this problem? The best way to approach this problem is using a sliding window technique. And basically this means we are going to first need to identify how many total ones are in our array. So in this first example, we have 3 ones in our array. So we are going to use a sliding window technique, and we're going to look at 3 numbers in the array. If there's a 0 in one of those spots, that's going to count as a swap. So if we look at our first 3, there's 2 zeros, so that means we need 2 swaps. Second 3 numbers, there's 1 0, that means we only need 1 swap. 1 swap, 1 swap, 2 swaps, and then if we wrap all the way around, we'll start here and look like this, and we will need 2 swaps again. So we are going to use a sliding window technique. But how are we going to use a sliding window technique on an array that wraps around if it isn't wrapping around? Well, we're going to extend this array. We're going to take whatever the original positions are, and then we'll add however many extra ones there are to the end of the array. This means, because we have 3 ones, if we reach this 0, it'll only ever be able to reach 2 more positions after it as a wraparound. So we'll take this 0 and 1 and copy it to the end of our array, and that works as our wraparound. So let's code this. First, we're going to count our number of ones. We're then going to make a new array that is wrapped around by the number of ones or the number of swap positions that we need. Then we're going to initiate our sliding window and slide our window and count the swaps. We'll keep a variable minimum. That is the minimum number of swaps. So first, to count our ones, it's simply just going to do a for loop, and if it's equal to 1, we'll add 1 to our count. So we can have an integer count 1 is equal to 0. Then for int I is equal to 0 as long as I is less than nums.length, I plus plus. If nums of I is equal to 1, count 1 plus plus, and now we have the total amount of ones that are in our array. So now we're going to want to make a new array that wraps around. So how do we do this? We are going to extend nums by the count of ones. So in our first example, our array is of length 1, 2, 3, 4, 5, 6, 7. We have 3 total ones. So after this 7, we can add 3. This will efficiently wrap around our array. So we're going to have a new integer array, and we could call it new nums. It's be equal to a new integer array, and it's going to be of length nums.length plus our count 1. We're then just going to do a for loop for int I is equal to 0 as long as I is less than our new nums.length, I plus plus. And if I is currently less than nums.length, so between 0 and 6, we are going to simply new nums is equal to nums of I. New nums of I is equal to nums of I. Then when we wrap around, so else Once I reaches 7, 8, 9, 10, we're going to want new nums of I to equal nums of nums.length minus I. So 7 minus I, once I reaches 7, we're going to hit this else part. So nums.length, 7 minus 7 is 0. So new nums of 7 will be equal to nums of 0. Then nums of 1, then nums of 2, then nums of 3, efficiently wrapping around the old array for the new array. After that, we're now going to want to initiate our sliding window. So our sliding window is going to slide through this new array, check how many zeros are currently in this window, and that's how many swaps need to be made to fill or connect all of our ones. So for our sliding window, we're going to initiate a variable called swaps. So int swaps will be equal to 0. Then we're going to do for int I is equal to 0 as long as I is less than. I is going to be less than count 1. So I++. Why are we using count 1? Well, this is because we're initiating our sliding window. We are going to set the original amount of swaps needed, and then each time we iterate, when we're in this bottom loop, we are going to subtract whatever's at the back of our window and add whatever's at the front. So if we start here, this is where we initiate 0, 1, 0. Our next window is going to be 1, 0, 1, so we'll subtract this 0 and add this 1. That's all we have to do for our sliding window, and however many zeros we have is how many swaps we need to make. So what we could do for this first loop is if new nums of I is equal to 0, then we're going to do swaps ++. And then otherwise, we don't need to do anything because the 1 just stays where it's at. Now for our final loop, we're going to want to identify an integer minimum, and that's going to be equal to our current swaps. And minimum is going to be updated every time we slide our window to find the new minimum number of swaps we need. So for int I is going to be now equal to count 1 because we went up but not on to count 1. So int I is equal to count 1 as long as I is less than new nums.length I++. And now we're just going to have some simple logic. If we are incrementing our window, we need to get rid of what was at the back and add what's at the front. So if new nums of, and then we're going to do I minus count 1. So let's say we're adding count 1. So count 1 is equal to 3. In example 1, count 1 is equal to 3 because we have 3 ones. So if we're starting here at our third element, 0, 1, 2, 3, we are going to want to get rid of the first element. So 3 minus 3 is 0. We're getting rid of the 0 element. So if new nums of I minus count of 1 is equal to 0, we're going to do swaps minus minus. Then we could do else. Sorry, we're going to need to do else if new sorry, not else if, it's just a whole nother if. So if new nums of I is equal to 0, then we will add 1 to our swaps. So swaps ++. Then we'll identify new minimum. So minimum is equal to math.min of min and swaps. We can now return our minimum. And if we run this, sorry, up here we want to make sure that it's I minus nums.length, not nums.length minus I. So I minus nums.length, because I is going to be bigger eventually. So I minus nums.length. So if we run this, passes our test cases. And if we submit it, passes all solutions. Now let's do this in Python. So for our solution in Python, it's pretty much the same exact thing. Anyways, yeah. So our Python solution is pretty much the same, just a little bit simpler. So we're gonna have count 1 is gonna be equal to 0 for I in nums. If I is equal to 1, count 1 plus equals 1. Then we're going to make our new array. So we're going to have new nums is equal to nums plus nums of, and then it's going to be from 0 to count 1. Pretty sure. Then we are going to initiate our sliding window. So we're going to have our swaps is equal to 0 for I in range of count 1 if nums, we do new nums of I is equal to 0, swaps plus equals 1. That should initiate our sliding window. And then we could do min swaps is equal to swaps. Then for I in range from count 1 to the length of new nums. If new nums of I minus count 1 is equal to 0. We could do swaps minus equals 1. Then we can do if new nums of I is equal to 0, swaps plus equals 1. And then we could do min swaps is equal to minimum of min swaps and current swaps. Then we should be able to return our minimum swaps. So if we run this, passes our test cases, and if we submit it, passes all solutions. Thank you, and follow for more daily LeetCode solutions.